Hi everyone, welcome back to another video. In today's video, I'm going to be talking about haloform reaction. Haloform reaction के जो reactant है, it is nothing but your methyl ketone or a methyl aldehyde. Okay, what is a methyl ketone and what is a methyl aldehyde? We'll just see. So this is a ketonic functionality, right? Now मिथाइल कीटोन होता है कि कीटोन फंक्शनैलिटी के जस्ट साथ में एक मिथाइल ग्रुप तो एटलीस्ट होना चाहिए, ठीक है। उसके अलावा कोई भी ग्रुप हो, इट डज नॉट मैटर, बट एटलीस्ट एक मिथाइल ग्रुप शुड डेफिनेटली बी देयर एंड दैट इज बेसिकली व्हाट इज कॉल्ड अ मिथाइल कीटोन। ओके, if I talk about an aldehyde here, so this is an aldehydic functionality, right? And aldehyde के साथ at least एक methyl group तो होना ही चाहिए, that is your methyl aldehyde. But of course in case of aldehyde, only this aldehyde is possible, right? क्योंकि इस तरफ हम ग्रुप को चेंज तो कर नहीं सकते, ये तो हाइड्रोजन ही रहेगा हमेशा, unlike your of course ketone, ठीक है। ketone में तो you can change groups on either side of the group, but in case of aldehyde, this is your entire functionality. So you can only keep changing the groups here. So if there's CH3 here, that's well and good, okay. But again, if you keep increasing the number of carbons, the group will become ethyl, propyl, butyl, and so on. So in case of your aldehydes, only this particular aldehyde, which is ethanol, can perform haloform reaction. Whereas in your ketone, there can be a number of ketones which can perform this reaction, okay. So our reactant is a methyl ketone or ethanol, okay. If you're talking about aldehydes, on reaction with a base along with your halogen gas, okay. This halogen gas can be chlorine gas, bromine gas, iodine gas, depending upon different gases you take, you will get different products, and you will see that in a while why. And the second one is your acidic workup, okay. Why this workup is important is you'll know that in a while, but sometimes this step is missed, but we must know the importance of this step also. So if I'm considering this particular ketone, this the one which is in red, the products that you're expecting is a carboxylic acid group along with a haloform, okay. Now this is a carboxylic acid, okay. Of course the corresponding acid of the corresponding ketone that we have taken, and this is your haloform. Haloform meaning if there is the halogen group is, let's say, chlorine, we will be getting chloroform, okay. If this halogen was chlorine, we would have gotten chloroform. If this would have been iodine, we would have gotten, of course, iodoform, okay, and so on and so forth. So before starting with the reaction, I will just like to convey that basically we are going to convert nothing but a ketone into a carboxylic acid, means this is nothing but an oxidation reaction, okay. So always remember that haloform reaction is nothing but a reaction that converts ketone into a carboxylic acid, which is very much an oxidation reaction, okay. So now let's start with the mechanism of the reaction, because, well, why not. So if we talk about the mechanism of this reaction okay, at every step we can ask ourselves some questions and we can answer that as well, okay. Now let's start. So we have a methyl ketone, okay. In this case, it is propanone. Now we attack this group, which is the propanone, with a base, which is OH minus ion, okay. This OH minus ion, of course, has come from NaOH, which of course I've added, This OH minus ion is going to attack the hydrogen which is present here, which will result in formation of a conjugate base, okay, minus water, of course. OH minus has taken this hydrogen, removal of water takes place, and you will be getting a carbon ion here, okay. This ion is called an enolate ion. Why? Because this ion can travel like this, and in resonance you can get this particular ion, okay. Both these are in resonance, okay. But one can argue, why does this carbon ion go further and not this O minus? So I'll answer that in a while as well. But you have to know that this ion, these two ions are called enolate ions. They are in resonance, and this is the most important step here, because you need to understand the chemistry of enolate ion before we understand the chemistry of haloform reaction or any other reaction which comes from the enolate ions, okay. So this enolate ion, this particular canonical structure is going to go further, okay, and is going to attack your halogen gas, okay. Halogen gas here, if it could have been chlorine, it could have been iodine, I have taken XX, you can just fill up the X depending upon whatever gas you've taken, okay, is going to attack this one, and there's going to be a heterolytic cleavage here, and you will be getting CH2Cl. If let's say this X was Cl2, okay, and of course 1 Cl minus ion will be out because heterolytic cleavage took place, right? Now these two hydrogens which are left are now even more acidic, है ना? If you don't know why these are even more acidic, you will have to look into the chemistry of it. If not, you can of course comment down below. I will tell you why this is more acidic, but if you know it, that's great. Okay, now the base is going to attack this hydrogen again, and again you will be getting a carboxylate, a conjugate base, CHCl minus, and again this conjugate base is going to attack your halogen gas here, and again a heterolytic cleavage is going to take place, and you will be getting CHCl2. Okay, again this hydrogen, the last hydrogen is most acidic, right? Of course you know why. And now again this is going to be attacked by the base. Okay, and again you will be getting a conjugate base here, something like, which looks something like CCl2 minus. Okay, now this is again going to attack your halogen gas, again heterolytic cleavage took place, and finally you have CCl3. Okay, now this group is the group which you get finally when you have no hydrogens left for your OH minus to attack, and now you have again an OH minus ion in your medium. Okay, now this OH minus ion can do two things. Either it can go and attack here, which is the electrophilic carbon, or it can go and attack here, which is again a acidic proton. Okay, for the reaction to go further and for the products, the expected products to form, okay, this OH minus comes and attack this electrophilic carbon. Okay, and the bond goes up because we have to maintain the 4 bonds of carbon. Okay, and this looks something like this. As and when this O minus comes back, this becomes a leaving group. Okay, this will take away its bond pair of electron and will look something like this. We get a carboxylic acid group here, okay, and along with that we get a negatively charged group here, which is a leaving group. Okay, because this leaving group along with the bond pair, it took the electrons and then went out. It became the leaving group along with the bond pair. That's why we have a negative charge here. Okay, now this is acting as a base, and of course this is a carboxylic acid. Of course this is going to be an acid base reaction, and this is going to attack this proton here. Okay, and you will be getting CHCl3 and your carboxylate ion. Okay, now is when you see why your acidic workup is important. ठीक है, अगर acidic workup नहीं होता तो इस stage पे your reaction would have stopped, because now we have to neutralize this carboxylate base, right? Carboxylate ion. Carboxylate ion is now neutralized by this particular acidic workup here, and you get your haloform, which is your chloroform in this case, and you get the product. Okay, this is the carboxylic acid and the chloroform group. So the most important key points of this reaction is you have to look for methyl ketones for the reaction to take place. Okay, you have to look for reagents which look something like NaOH-X2 or sometimes NaOX भी लिखा होगा. ठीक है, that is also the reagent which could have been written. And even though sometimes the acidic workup is not there, you have to still assume, okay, that the acidic workup was definitely there. This I'm only saying for the people who are in class 11th and 12th, but for higher classes acidic workup must be there, because otherwise you have to stop the reaction at this stage. ओके, एसिडिक वर्क जब तक नहीं होगा तब तक ये हमारा कार्बोक्सिलिक एसिड नहीं बनेगा. यू विल बी गेटिंग अ कार्बोक्सिलेट आयन ओनली, राइट? सो दिस इज योर haloform reaction. This is the most important, one of the most important reactions in chemistry. So thank you so much for watching. If you have any doubts, you can comment that down below. I will try to answer them. Thank you so much for watching.